Welcome. In today's episode, we'll discuss functions and clusters in Grasshopper and Python. Let's get started. Okay, so within our Rhino environment, I already have prepared a script node, and I will start writing a function. So what is a function? Well, a function is a repeatable piece of code because let's say we have some functionality. Let's reproduce maybe the way to compute the average of some numbers. Okay, let's say we have a list of numbers. So let's say numbers is whatever 10 31 minus 1 77. Okay, just a random list of numbers, and then we want to compute the average of those. So what is the average? Well, we just do 4. It's just the sum of all the numbers, then divided by the number, the amount of numbers in the list. So we need well, the length of them, which is just len of numbers. Okay, this will be the denominator. And then the numerator will be the sum of all of those. How do we do that? Well, we can use a for loop. So for n in numbers. Okay, we'll do a total, which is just equal to 0 at start. And then for n in numbers, we'll just take total, and add the current number, so that at the end of the for loop, total will be the sum of all the numbers. And then we can divide this total by the length of numbers, and this will be the average, and we can print it out to the screen. So let's print the average. There it is, in this case 23.6. So let's say we wrote this nice piece of code, and then we want to use it in another component, or we want to use it in another piece of our same code. So let's say, well, whatever, we write a bunch of code right here, we get to the down here, and then we want to use average again. So to average another list of numbers. So we would need to rewrite this same thing, and instead of these numbers here, we would need another list of numbers. So let's say numbers 2, and we put in another list. Let's say 3, 5, 6, and 10 minus 124, whatever. And then we would have to drop in numbers number 2, then say average 2, and then print average 2, and indeed you get the result, but we had to repeat this piece of code 2 times. So let me actually delete the spaces in between. They were just for an example, and this is not very efficient because we are writing code multiple times. This version could be different than this version, and it's just not nice to have to rewrite the function multiple times. So to do that, to write this functionality multiple times, we can actually do a thing called functions. So let's define a functionality. To do that, we just write def, which is define. Then the name of the function, let's say it's compute average, okay? And then this takes a certain array of numbers. So let's call it numbers array, okay? And then it will execute this piece of code. So we can indent it in and like this. So it will take a total, initialize it to 0. So for n in not numbers, but numbers array, it adds it to a total. And then it does average total divided by the length of numbers array. And then it, instead of, like, it has to give back the value of the average. So to do that, we use the return keyword and then return average. And we say it. So we just define the function. So nothing gets executed, but now our script knows about this compute functionality. So we can just call it on a different arrays. So we can do maybe A1 will be the average of the list numbers 1. So let's do numbers 1. And to do that, we don't have to rewrite all this piece of code. We can just take the name of the function, compute average. So this is the definition of the function, and this is the calling the function, invoking the function. If we open up the brackets, and then we can drop in the value that we want to compute the average on. So in this case, average number 1, and then we can print this A1, and we get the same value as before. And we can do the same thing for A2. We just have to change the argument, the name of the variable, and we will reuse the same functionality, and we get the result again. So this is very nice and very tidy. So we can do one last thing, which is commenting this function. because you see that once I use, we already saw actually functions, we just haven't defined our own. So when you do print, for example, and you open up the brackets, you see you have this this pop-up message that tells you what the print value accepts, what it returns, and then a description of the functionality. We would like our own function to have that thing as well. So to do that, we can just write a comment, a multi-line comment at the top of the function. The first line will be the description of the function. So this function computes the values, the average of some numerical values. Okay, so that's the description. And then indeed, if you call compute average, it will tell you the description of the function right here. Another thing we can define is the type of the suggestion for the type of the argument. So we can say, well, this is a list of floats, maybe with a small l. Yeah, I believe so. Maybe with square brackets. I never remember this stuff. Yeah, actually, let's do something clever. So since remembering the syntax of this is always a little complex, let's just write and copy the function. Let's just put it any LLM, and then let's ask him to write the comments for us. So write the comments so that IntelliSense works. Don't change anything else in the function. All right. And this is a very good use of AI, of LLMs, because writing descriptions is always kind of boring. And indeed, you see, we get these nice comments. So let's just take it in like that. These raises we don't care about. Okay, and then list float. Okay, it just uses square brackets, and it was working. So let's just do that. Let's just copy the entire function, and let's drop it in there. So we have our same function as before. Average is the list, float is the type of argument, and then this returns a float as well. Okay, and then this is just the description of the function. Then we get args, which is describing the list of arguments. So we get the first argument called the numbers array. It's of type, it's a list of floats, and it's a list of floats and integers to be averaged. And then it returns a float, so a single value, which we also said here, it returns a float, which is just a calculating average. And then it raises a division error if the list is empty. Okay, this is just what happens if you provide a wrong argument. And then indeed, if you go down here and you try to compute average again, and you open up the brackets, you have this all complete description of the function. So you have numbers array list float that returns, so it has just one argument, which is of type list float, and it returns a float as a result. This is the description of what the function does, and then I closed it, but yeah, this is also all the other stuff. And I believe you can also call help on it. Let's try. If I just do help and then this, it will do the same. Yes, so if you do help on the function which has that comment, it will bring up all the comment down here, so you can also see how to use it. And whenever you define new functions, it's a good idea to define these comments so that even yourself can remember what the function does and how it's expected to behave whenever you use it in code. All right, so these were functions in Python, in the Python environment. So what about Grasshopper? So how do we do functions in Grasshopper? Well, there's not really an actual function thing, but there's a very, very similar concept called a cluster. So let's reproduce the same example of the averaging numbers with clusters. So, I mean, just so that you know, there's already an average component, so you could use this. So we will just try to take and reproduce this average component. So let's keep it up there so we can reproduce it in the same way. So the first thing we said is we need a list of numbers. So let's say number. okay, like that. And then this list of number has to be summed, so it's a mass addition, so it's a mass addition, like that. And we drop it in. So the result, let's just drop in a list of numbers so you can see it while I develop it. Okay, and 4, okay. Multi-line, let's drop it in, okay. So the results are just, this is the sum of all the numbers, and then we need how many numbers there were in the list. So there's a list length component, so we can get the list length of this. This is 6, and then we can just divide the total by the list length. So let's do that. We divide the total by the list length, and this is going to be our average result, which we can just drop in here, 12.333 in this case. And you see that if I take the same thing from numbers and I drop it in the input, and then I inspect the result, we indeed get the same thing. So the functionality is working now. But again, this is not great because if I need to use this stuff again, I would need to take these, make a copy, and then take another panel, maybe with different values. Let's say it's 10, this one, and drop it in here, and you get a different result. And then every time you have to take this, make a copy around, and it's not good because you fill up the canvas very quickly. So can we define a function like thing? Well, yes, we can with clusters. So let's do that. So I will just delete the example, and I will also define this number thing. So let's see how this compares to the Python implementation. Let's drop a bunch of comments in. So this is something I always like to do with clusters. So we have inputs here. So we have inputs. And within the inputs, I define the type. So this is the number. So it will only accept numbers. If I drop in something else, it will either convert it to a number if it's possible, or just give an error. And then we need an input component. So it is called cluster input. So we need to define that this thing will take inputs from the user. So let's drop it in. And then the same thing, we have an output. So this is the same as the return statement. So we are returning, in this case, one value, which is this number, okay, like that. And I like to just write outputs right here. So output there. And then I like to group this. So you select them all and then right click whatever you want in the canvas. You can group and it'll group them. So group again. And then I'll describe, in this case, it's very easy because we only have one operation. This is just computing the average, okay? And I will also enclose this in a group. So this is a very nice implementation of the cluster. So now we can select all of it, right click wherever you want on the canvas and hit cluster, and you see it will be brought together in a single repeatable object that you can then bring around just like this average. Of course, there are a couple of things that you don't like about it. One is the icon. We will not deal with the icon today. We'll do it in another video specifically on that topic. But if you right click on the icon and then you see like to the right of the name, you have this bucket. If you click it, it will actually display the name. So it's, in this case, we don't have an icon, so we prefer to have a name. Let's call it with the same way as this one here. So it's called average. So to do that, we right click, we do properties. This thing comes up and we have a name and a nickname. So let's call it average in both cases. So average and average, okay. And then there's a description of what it does. Let's copy it from here. So solve the arithmetic average for a set of items. So let's copy that in. So solve the arithmetic mean of a set of items. In our case, it's not a set of items, really, it's a set of numbers. So let's write our numbers because this component also works with other objects. We did just one that works with numbers. All right, so now we see its average, and if you go over it, you will see solve the arithmetic mean of a set of numbers. Very nice. And then something else we can do is we can well, either double click on it or right click edit cluster. You will open up the definition of the function or of the cluster if you prefer, and we can then define the names of the inputs. So you see that this as a name, it's input, and it has a description, and it's also defined as a list in this case, and this is called arithmetic mean, which is the output. You can also go display and draw full names and see just a shortened name of these. So you have I and you have AM. So let's use those same numbers. So we will say the name is items, I believe. Items. In our case, let's call it numbers because it makes more sense. Let's call them numbers. And then this is the nickname. And then the name is just N, which is the short one. The numbers to average. Okay, with the dot. And then we'll do the same with this this output here. This is the arithmetic mean. So it's just AM arithmetic mean. All right, and this is the mean. Okay. So if you then right click on this box, save and close, it will not update, but it actually works. It's because there's a sort of a bug in clusters. They don't update automatically, but there's a plugin you can use. It's called Pancake. If you install it, I did a video on how to install it. I'll put a card up here. And then you can go to cluster operations, refresh param names, or refresh automatically. In this case, let's just do refresh param names. You will see these got correctly correctly changed. And if you hover over it, this says the mean, and this is just the numbers. Okay, I maybe switched the nickname and the name, but it doesn't really matter. Okay, and then let's try it out so that we can test if it works. So let's say a bunch of numbers. Let's make it a multi-line data. Let's drop them in here. In this case, since this is not meant for numbers, it's meant for items, we have to tell him that they are numbers. Let's do that. All right. And we can check the average. That one is. Okay, and in our component, it already knows that they're numbers, so we don't have to change it. And indeed, we get the same result. And we get this nice element that we can reproduce. We would also like to add it to the toolbar. So let's see where this average is. In this case, it's the math and utils. Let's say we want to add our own tab up here and add this this thing so that we can save it for later. Let's do it. So we will just select it. And after you select it, you can go to File, Create User Object. So create user object. And let's just say it's called average. It does that. Category user. So it will add the user tab up here. Default, it's fine. Let's maybe do math. Why not? Under one. And then let's say, okay, we will not define an icon in this case. Go okay. And you will see that up here within user, if you click on it, you have this math component that you can drop in just like that. And as I suspected, I flipped the name and the nickname, but it doesn't matter. So if you do drop full names and then you drop it again, you will have the short description. They're flipped, so just go in and change them in your version so it will work correctly. And there's just one limitation. If you do and change the display name, you see that the baked components, the compiled components will switch automatically. This one will not. It will only remember the option that you used once you plugged it in, which is not a huge deal, but it's a limitation that it's there. So it's better if you know that. And of course, if you then take this one and you make changes to one of them. So let's say I just add whatever text in here, which doesn't do anything, but it's still here. And I save this, so I change this one, and then I open up this one. You see the change is propagating in all of them, so it's actually behaving exactly like a function in Python. All right, so I think that was enough for today's video. You saw how to do functions and clusters in Grasshopper, which is a very similar concept, which I think is very useful, and it's not used enough in the script that I see around. So I hope you found this useful. If you did, leave a like. Subscribe to the channel and see you next time.